All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 119 is on the screen. Also, you will need your Chromebooks. Also, I need you to set up 8 coordinate planes from -10 to 10. Once you're done with that warm-up, 8. Focus. Go. All right, so being that it's Monday, let me go over that warm-up one more time just to make sure we got it. So, for f of x equals 2 to the x minus 2, focus, Jacob, equals to 2 to the x minus 2. We're going to substitute -5. So this becomes f of -5 equals 2 to the -5 minus 2, which is 2 to the -7, which is 1 over 2 to the 7th. Is that correct so far? Yes, Mr. Q. And if you multiply this one out, that was, let's see, 2 times 2 times 2, that's 8, 64 times 2, that's 1 over, let's see, 2, 8, 64, 128, something like that, yeah? So that means f of 0 was, let's see, 0 to 1/4, and f of 1 is 1/2. Hands if you got something like that. All right, not bad. And the process for this one is the same as this. However, we got f of -5 being 1 over 10 to the -6, which is 2, 3, 4, 5, 6. 1 million. F of 0 is 1 over 10. And f of 1 is 1. Something like that. All right, transformation, I'll leave that to you. By now you should know what to do with each component. So, before I go though, look up. Tell your neighbor what this does to the entire function. What does that do to the entire function? Enlighten us, Brandon. Darty. It shrinks it, yes, vertically. So instead of stretching it, it shrinks it like so. And then you move it according to H and K. Okay. 3a, it's 1 over a to the 23 microjoules. B is equal to 1. C is 1 over, oh, no, my bad. It's 1 to the -3rd over 3 to the -3rd. We can't have negative exponents. So this goes in the numerator, this goes to the denominator, so that is 3 to the 3rd over 1 to the 3rd, which is 27. Ooh-wee. Oh yeah, I got this in my sleep. Did I tell you the story about me teaching my wife math in my sleep? No? No? So we were, one day she like threw an elbow on me like asleep, and I'm like, hey, she's all, well, stop it. I'm all, what? Well, I don't know, you're trying to teach me math. I was like, what? She's all, yeah, you were saying something over something, so I was probably teaching her rational expressions or something, and then that I told her, like, answer. And she's all, what? And that's when she elbowed me. She elbowed me that I did this. I imagine getting an eraser and I erased the board like that. Let's go. In my sleep, I got this. Anyways, this is 4 to the x times 4 to the -2, which is 4 to the x over 4 to the 2nd, which is 4 to the x over 16. Something like that. In our sleep, we got this, yes? Yep, some of you are waking up like, rational functions. Oh yeah, we got this. Copy, copy the agenda, please. Warm-up 119 done. We're still in the middle of rational functions. Hopefully you guys did well on Friday with that pop parte. We only did two things, or two problems of each, one for graphing and one for writing. Today we're going to be looking at this in regards to the scope of transformations, though. Still graphing, but using transformations, okay? So, with that said, copy that, and I'll give you guys some time to set up 8 coordinate planes from -10 to 10. So if you're following on YouTube, do that right now. Get some coordinate planes ready. And here's the code to have access to the home play and to this presentation if you are following behind with the notes. Here's the code. Write this down. I5YSM. I5YSM. That'll give you access to the home play and to the presentation from today. All right, I'll give you guys some time. Set up your coordinate planes, please. A couple more minutes. Go. All right, as you're finishing up your coordinate planes, once again, there's a code for your home play. And also, I was supposed to collect a home play on Friday. Sorry I wasn't here. But it's this one. Make sure you turn that in on Canvas right now, please. Those 2 pages, 6 problems. I'm sorry? For that one? For right now? Oh, yeah, give me a second. So make sure you turn that in. It was 4 that you graphed and 2 that you wrote the formula or the equation. Thank you. And this is the home play for you tonight. But you have the code. All right. Give me a second. All right, here we go. Our objective for today, I can write, solve, and graph rational functions. So far, we got the writing, the graphing done. We're very close to continue solving rational functions, which we started last semester with rational equations. However, remind your neighbor the definition of rational functions. Turn to your neighbor, let them know what that is without your notes. Rational functions are. All right, pretty close, yes? An equation that contains one or more rational expressions, there they are. This is what they're not. And here are hashtags. You have those notes. You don't need to write it down again. So, from there, we went to steps to graph. What were they? Identify the vertical and horizontal asymptotes. From there, we build an input-output table, and we graph. Remember those, yes? However, right there, we moved on to the ones that needed to do long division, and then we moved on to writing an equation from the graph. So by now, everybody should be unstoppable on these, yes? Pretty good, right? All right, all right. And then we talked about the general rule, getting to this, and we said that H and K do still the same thing, right? Remind your neighbor how K affects the transformation of that function. What does K do? All right, what does K do, Danny? Up and down. How about H, J? Yeah, left and right. How about A, Martin? Yeah, he said shrinks or stretches vertically. That means that B does what? Rylan. Go ahead, Martin. Yeah, stretches or compresses horizontally. That is correct. However, H and K are also, once again, what are they called? Asymptotes. Those are our vertical and horizontal. These are the easy ones. We're getting close to going to the slant or oblique kind. So once again, reminder, H is our vertical, K is our horizontal. So this drops us to today. Today I'm going to show you something that is very doable in regards to transformation of rationals. So, writing utensils down, look up to the screen. Let me pause the music. All right. So, Writing utensils down, eyes on the screen, stay focused, Jacob squared. Here it goes. So, all right. So when we got to graphing parent functions, I remember I had an exercise so that you guys can graph it like automatically. It was like muscle memory. So we know how to graph f of x equals x squared. Is that correct? All right, tell your neighbor the 5 points that you would place on the graph for that parent function. Very good. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Right now you're just paying attention. Look at this one. F of x equals x cubed. Remind your neighbor the 5 points that we would place for that one. What are the 5 points? Very good. -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. And it would look something like this, with a little wiggle. Yeah, does that look familiar? Yes? Okay. Next, f of x equals x, what we started with, linear. So my 5 points are here. -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, straight line, and so on and so forth. So, check this out. Turn to your neighbor and let them know from all these 3 parent functions, what point do all 3 use? What point do all 3 use? All right? Some of you are like, well, Mr. Q, they all use 0, 0. Okay. How about 1, 1? Yes, all of them use 1, 1. And the reason I'm pointing out 1, 1, because check this out. If I was to use this same idea of graphing for my parent function f of x equals 1 over x, isn't that irrational? Yes? So, look up. First, what would be my VA? Remind your neighbor, what's our VA for this one? 0, that is correct. How about our HA? What is y equal to? 0, because there's nothing there. So that means I do 0 and 0. However, if I was to get a table going, predict what point will I also use just like the other ones. What point will I also use just like the other ones? What point, Anthony D? 1, 1 is correct. Here it is. There's my graph. So if there's a point here for this rational, there should be one at what? -1, -1 as well. So the reason I'm bringing this up today is because for transformations, we're going to be using this idea, but we're only going to be using 0.11 for rationals and -1, 1 for the other side of the rational. So far so good, yes? All right. So with that said, look up to the screen. Let me go to here. All right. So here goes what we're going to do today. We're going to graph f of x equals 1 over x. So copy that on your first coordinate plane. F of x equals 1 over x. And this is exactly how the home plate is going to go. Okay? So please, pretty please, be doing your practice instead of copying people, because at the end, your muscle memory is not kicking in for those parts because you're copying from people. Bah! So, what do we do first? Tell your neighbor, and then Meadows is going to enlighten us. What do we do first to start graphing? What do we do first, Meadows? VA. VA equals, since there's nothing next to the x, that means this is, VA is x equals 0. Okay. Next, HA. Meadows, and that is 0 as well, because there's nothing here as a constant. All right, so let's sketch those. So y at 0. X at 0. All right. And you make those points a little bit bigger. Where's those stashes? Oh. All right, there it is. Okay, so next we're going to graph this. Since this is the parent function, and Anthony D told us to use which point, Anthony D? 1, 1, so place it there. And then you graph this side of the rational. And then there should be a point that mirrors that one on the other side over here, yes? So it should be at what? -1, -1. So far, so good, yes? All right. So, before I get into the domain and range and all that, I just want to make sure that you understand this part. So, from 1 to 5, how comfortable are you with that for home plate? We good, right? 5s? Yes. All right. So now look up, please. What if I asked you to transform this one, this is the parent function, to look like this? G of x, write that underneath. 1 over x minus 3, and then at the end, a constant of plus 4, plus 4. So, writing your utensils down, look up to the screen. Let me show you something to make sure you understand what we're looking at. Writing your utensils down, look up to the screen. So what am I asking? Mr. Q, you're asking me to graph this one as well. Yes, but do you have to do all that process as this one? No, not really. So then what do I do, Mr. Q? Well, let me show you. By looking at this, it's going to move this function in which direction? Talk about your neighbor. Where is that going to move the original function to? Where will that move it to? Anthony D, pass someone. Claire, where's that going to move it to? To the right, how many steps? So 3 to the right, and 4 up. So what Claire is saying, look up to the screen before you start doing anything. Look up, please. Watch. I'm going to move the entire graph 3 to the right and 4 up. Look up, please. 3 to the right, 1, 2, 3, and 4 up. 1, 2, 3, 4. Do you see where it's going to end up at? But what do you guys notice? Did I only move the little curves? No, I moved everything, including what? The asymptotes. Does that make sense? Therefore, it should end up being right there. So let me take this back, put it back where it belongs. So this is what I need from you. For the home plate, to get started, you're going to start with the parent function, which is this. And then, check this out, look up. At this point, when you see the transformation, then just identify your VA, x equals, everybody, that's at what? 3, and our HA is at, what is it? 4. So do that right now, please. 4, 3, and then look at this point. 1, 1 is from where both asymptotes meet. It's one step up, one to the right. So look up. From here, it's one step up, one to the right. And from here is one step to the left and down. And that is our g of x. Pretty straightforward, yes? From 1 to 5, I'll come to where are you with this? All right, some 3s, 4s, okay. So, this is exactly how the home plate is going to go. So do me a favor, let's go to the next coordinate plane. Next to it, copy this one, please. Example 1, g of x equals 1 over x plus 2 minus 3. G of x equals x plus 2 minus 3. Equals 1 over x plus 2 and then minus 3. So what do we do first? Well, we're going to graph f of x equals 1 over x. This one is what? F of x. When you graph g of x, guys, the graph, I want it in green or a different color. So like that, it shows me that you did the transformation. So here we go. For the transformation, what is the VA and the HA? Tell your neighbor, please, and then Brandon's going to enlighten us. VA and HA. What is our VA? What is our HA? All right. Brandon, Felix, VA, -2, and HA? That is correct. Let's do that. -3 is down here. -2 is over here. And the new graph, look up, here it goes. From this point, it should be 1 up, 1 to the right. There it is. 1 left, 1 down. And this is our g of x. From 1 to 5, I'll come to where you with this one. Yeah, we got some 5 4s, a little bit better, yes? And that's a x. Oh, yes, no. All right, so I did one with you. Copy this next one to the next graph. Example 1Q, g of x equals 1 over x minus 6 minus 5. Do that one by yourself. Remember, start with f of x and then move to that. Go. All right, show your neighbor your graph really quick, and then Brandon and Felix is going to pass it to someone. He's going to help me. They're going to help me graph this. All right, Brandon, Felix, pass someone. Danny, what's our VA? I'm sorry? Our VA? 6. Okay, so right here. And our HA? -5. Oh, okay. Yeah, don't flip them around. All right. Next, give me a coordinate for one of the points that you plotted. -7, -4. That is correct. And the second one? 5, -6. That's our g of x. Hands if you got that by yourself. That is correct. From 1 to 5, how comfortable are you with this? Yeah, we got this, yes? All right. Send that in. Make sure you send it in. Now look up. Look at this one. Don't copy that. Look up. Look up to the screen. Tell your neighbor where we're going to move this one to at the end. Where are we going to move that to? We're going to move it, how many steps to what? Danny, pass someone. Rylan, where are we moving that to? To the left, how many steps? And what? 3 down. Okay. However, this one has something in particular. Tell your neighbor what does it have that we need to do at the end? Rylan, what do we do at the end? That is correct. Remember this. You write hold, and then at the end you what? Flip all the points according to the asymptote. Okay? So, with that said, let's go to a funner one. Let's go to this one. Copy this one on your next graph. G of x equals 2 times 1 over x plus 5 plus 4. So to get us started, I'm going to start with a parent function, f of x equals 1 over x. All right. Rylan, pass someone so they can help me graph this new transformation. Who? Who? Oh, Jake. VA x equals. -5. That is correct. So it's over here. Let me show that. And our HA. Okay, let me move this up really quick so I can have more space. And Jay said our HAY equals 4, you said? 4, okay. All right. Okay, before you graph the transformation, look up. This one's a little bit different. Look up, look up, look up. Writing utensils down. Write your utensils down. Look up to the screen. What do you guys notice different on this one? The 2, is that correct? Well, guess what? What did that 2 do to all the other functions? Tell your neighbor. What does that 2 do to any function? What does it do? All right? Anthony, E, what does that 2 do to any function? Yes, it multiplies. Yes, that's true. But what does it do in regards to the transformation? We said it at the beginning. It stretches. That is correct. Vertically. If it was a fraction, what would it do, everyone? Compress. That is correct. In this case, how does it stretch, Mr. Q? Well, instead of being here, look up. Instead of being at 1 step up, 1 to the right, it's going to be at how many steps? 2 steps up, 1 to the right. That means 1 step to the left and 2 steps down. And that's how our graph is going to look a little bit more stretched because of that point, which was at 2. That's what we call g of x. Once again, look up. This is how I did it. I started here where both asymptotes connect. The multiplier was 2. That means I go 2 steps up and 1 to the right instead of just 1 and 1. And down 2 steps and 1 to the left. From 1 to 5, I'll come through. Are you with that? We got 5s? Okay, let me send you the screen so you can send me your notes. Give me a second. All right. And we arrived to this one. Look up to the screen. Look up. Don't copy this. Doesn't this one look different? Yes. Tell your neighbor what you need to do to this in order to make it look like the ones we've been working with. Anthony E, pass someone. Anthony D, what do we need to do here? Long division. And we'll stop right there. All right? Once again, make sure you do your practice at home, guys. Enjoy your home play, and I'll stop the video right here. Bye.